Hello everyone, this is a demonstration video for task 5.1p documentation. So, my name is Mayank and let's get into the demonstration. So, firstly, this task focus on implementing Open API documentation for a web API using the Open API specification, which is OAS, in the Swiss Buckle library in the ASP.NET Core. So, the key learnings from this task are understanding the importance of clear and concise documentation in the software development, especially in APIs to improve maintainability and usability. Second, learning how to use the Open API specification (OAS) and Swiss Buckle library to automatically generate API documentation. Third, familiarity with ASP.NET Core middleware and services for configuring and customizing the API documentation UI. Fourth, knowing the XML documentation comments and their roles in providing auto-generated documentation and enhancing IDE features. Fifth, enhancing with static file usage and organizing project assets for UI customization. Sixth, ensure to lambda expressions and their use in configuring middleware and services in ASP.NET Core application. So now let's jump into the so this is the program.cs file, and now let's jump into the code. So firstly, uh, these are the lines which import the necessary namespaces libraries required for the application. That is, system reflection is used to access assembly information, and robot controller API.persistence is the it contains the classes related to data persistence, and Microsoft API models contains the models required for open API documentation. Now, moving further, we have the our builder object which initializes a new instance for web application builder, which is used for configuring our our application and build our application. Then we register the services and required controller and endpoint routing using the builder.services add controllers add endpoint API explorer with these two lines. So these lines adds the services required for controller and services for API exploration. Now, moving further, we got the block for add swagger gen. So, this block of code configures a Swiss buckle to generate open API documentation. It specifies the API version, title, description, and contact information. Additionally, it includes XML comments from the assembly's XML documentation file, enabling auto-generated documentation for API endpoints. Then we we initialize the app for building the application using the configured services in middleware. And moving further, we configure our application is running in the development environment and adds a developer exception page middleware which displays a detailed error information in case of exceptions. And then the we are using the static files for such as the CSS JavaScript from the www root folder. Then we are using some swagger swagger lines. So these lines enable swagger UI for application documentation. Use swagger serves the swagger JSON endpoint, and the use swagger UI configures the swagger UI to display the documentation. The inject style sheet method injects a custom CSS style sheet the to customize the appearance of swagger UI. Then we have the our middleware to redirect our HTTP request using HTTP use HTTPS redirection. Moving further, we have the use authorization to handle the authorization for protected endpoints. Then map controllers to control routes for incoming request. And lastly, we have the app.run. This line starts the application and begins listening for incoming request. Now we have our two files which are robot command cs and map.cs. So the robot command cs contains the class definition for the robot command, which includes six fields, which are id, name, description, isMove command, created date, and modified date. Also, it contains the constructor for that for this particular class, which is public robot command with the defined parameters. Now, similarly, we have the map.cs. So, this contains the class for map. This is the map class, and it contains seven fields, which are id, columns, rows, name, description, created date, and modified. Similarly, here we also have our parameterized constructor for map class. Now, moving further to our robot commands data access file. So, firstly, there are some libraries which are used in this task, which are uh, like import the npj SQL namespace used for PostgreSQL for database connectivity. System namespace provides the basic types and functionality. System collection.generic namespace provides generic collection classes. Then we are using our robot controller API namespace. So this is a static class robot command data access within the robot controller API persistence namespace. So uh, it contains the methods for interacting with the database to perform CRUD operations, which are create, retrieve, update, and delete operations on the robot command objects. Then we are creating a private connection string, which contains the connection string required to connect to the PostgreSQL database. This string typically includes the information such as the host, username, password, and the database name. Now we have our first function, which is the get robot command function. So this function is used to retrieve a list of robot command objects from the database. It initializes the empty list to store the retrieved commands, and then firstly it uses the where connection. So this line creates and open a new connection to the PostgreSQL database using the connection string defined earlier. Then uh, then we create a SQL command to select all rows from the robot command table and execute the command using a data reader, which is gr, to retrieve the results. Also, the while loop is also it iterates over the rows returned by the data reader and populates the robot command objects to the retrieved data. Then we move to the update robot command. So update robot command method updates the n existing robot commands in the database with the provided updated values. And we have another function, which is insert robot command. So this function is used for inserting a new robot command into the list of the robot command object in the database. Then we have our last function, which is delete robot command. So this function is used for deleting any particular entry from the database related to the robot commands, and based on its ID. Now we have the map data access.cs. So this file works similar in a similar way, but for the map class. So same libraries are implemented here. And now moving on to the same, we have created one connection string for this, and then we have our first function, which is get all maps, this one. So basically this function, this method retrieves a list of map objects from the database. It initializes an empty list to store the retrieved maps. Then we are using a where connection. So these lines create a create and open a new connection to the PostgreSQL database using the connection string defined earlier. Then we create a SQL command to select all rows from the map table and execute the command using a data reader to retrieve the results. Moving further, we also have an while loop to which iterates over the rows returned by the data reader and populates map objects within the retrieved data. Then we have the update map function. So this function is used for updating the any particular map entry within the database. And then we have the insert map function. So this function is used for inserting any new map within the database using the new map object in the database. Then we have the delete map function. So this function is used for deleting any particular entry from the database using the map ID which is defined in the database. Now coming to the robot commands controller.cs. So firstly, we are importing the necessary libraries and namespaces for ASP.NET Core MVC, the robot controller API persistence namespace for interacting with the database, and other standard .NET namespaces. Then it defines a controller class for the map controller. And one second. Sorry. Then it defines the class for robot commands controller for the controller base, and the this class it contains the respective fields for the robot controller class. Then we are doing some XML commenting for retrieving our endpoints. And moving further, we have our first endpoint which is HTTP GET. So this endpoint is used for fetching the data from the robot command database from the robot command table to retrieve all the robot commands in the SQL UI page. Then we have our HTTP GET move endpoint for fetching all those commands for which the isMove command property is true, and it will return all those commands. For example, if we have 5 commands and for 3 commands the isMove property is true, and it will return all those commands. Then we have the HTTP GET ID. So this endpoint is used for fetching any particular robot command by using its ID, and it is done by the function which is get robot command by ID. Then we have the HTTP post endpoint. So this endpoint works with the function add robot command to insert a new robot command into the database and returning that particular output in the response body with the new added command. Then we have our next endpoint which is the HTTP port. So this endpoint is used for updating any existing robot command using the update robot command function. And firstly it will check that if that particular command exists or not with that respective ID, and if it exists it will update the command, and also it will modify the date. It will update the modified date with the current date. And but this function will not return any type of content indicating a successful update. Moving further, we have our last endpoint which is HTTP delete ID. So this endpoint is used for deleting any particular robot command from the database, and it will be done using the delete robot command method using the ID as a parameter, and this will remove the particular function or particular robot command from the database. Now we have our map controller.cs. So the map controller, now firstly we are importing the necessary libraries as shown in the robot commands in the robot command controller. Then we are creating a map controller class and defining a base route for our map endpoint. And similarly we have our same endpoints like HTTP GET for fetching all the maps, and we have the HTTP get square for fetching all those maps for which columns and rows are equal. Then we fetch any particular map with respect to its ID using the HTTP get ID endpoint. So this will fetch the map from the database which corresponds to the given specific ID. Then we have our HTTP post endpoint for adding a new map, for creating a new map in the map database, and this will check if the map exists or not, and it will add the map at the last in the list of the database. Like for example, if the ID for the last map was 4, then the new map will be added at the ID number 5, and it will return the newly created map in the response body. Then we have the HTTP put request. So this request is used for updating the existing map from the list, and it will not return any type of content in the response body which will indicate a successful update. Then we have the HTTP delete request, which will help us to delete any particular entry from the map database using the ID defined in the endpoint. And similarly, this will also not return any type of content. Moving further, we have our last endpoint, which is HTTP get ID x-y. So this endpoint is used for checking if any particular coordinate exists in that particular map or not. For example, if we have 5 maps and for ID 1, which has number of columns as 10 and number of rows as 20, and we are checking that any particular coordinate like 4 and 5, 4 comma 5 exists in the map or not, then we will check that if the coordinate specifies the condition for the map, and if it satisfies the condition, then it will return true, else it will return the false. Now let's execute the code. Now let's open the Swagger UI for this. So this is the Swagger UI for this task, as you can see. So these are the endpoints which are used in our task. For example, if we want to use this get endpoint, so we will click on this and then click on try it out. Then we execute this particular endpoint. On executing, this will show us the responses. For example, the status code is 200, which means that it is okay. In the response body, which contains the data which is fetched from this endpoint, like all the list of maps which are stored in the database. And similarly, we can do this for another endpoints, like for maybe map square. So as we can try it out, so this will return the commands for which the columns and rows are equal. And similarly, we can do this for the robot as well. For example, fetching the robot commands, as you can see, it will it is fetching all those commands from the database which are stored in the list, and we can use all these endpoints to fetch our desired output. So after fetching, we can generate the swagger.json file from by using this particular endpoint, and we can also create the XML file for this, and which is shown here, like which is the full web API.xml. So this is the particular XML file for this particular swagger task, and this is a swagger.json file generated from the above endpoints, which contains the information about the title, description, contact, email, etc., and all the paths related to the endpoints, like for all endpoints, post, get, etc., for both maps and robot class. So, as you can see, it contains all the data and all the schema, text, and JSON information as depicted in the UI of the task. So, this was all about the demonstration for the task 5.1p. Thank you for watching this video.